Welcome to Brain Vision.
We know that the force exerted by the magnetic field is given by I times L times B sine phi, where phi is the angle between L and M. And by Newton's law, we know that acceleration is given by F over M, and acceleration has to be a constant over here. Now, we can apply this constant acceleration equation to relate the velocity and the distance for the first part. So here phi is equal to 90 degree and the direction of force is given by the right hand rule. So magnitude of force is just gonna be I times L times B, and the direction is to the right. Let's mark it like that. For part B, let's use the kinematic equation that involves velocity, acceleration, and distance only. So that equation is basically Vx square is equal to V naught x square plus 2 times the acceleration and the displacement. This gives, so this is basically d, which we have to find, and initial velocity is 0. Acceleration we will find from here. So acceleration is basically force over mass. So that is equal to ILP over M. And since force is towards right, acceleration is also going to be towards right. And that's the reason why we used the x component equation, x-axis equation of velocity here. So that gives d to be equal to v square over 2a. I have just omitted the x subscripts over here. Nothing else. We can write that down if you want. So this is equal to, so Vx is basically this value, Ax is the one over here, and we get this to be V square over M, V square times M over 2 times ILB. So for part C, we are just going to use this equation now that we know all the values that we will be needing to find D. So we plug them into this equation and we find this value to be 1.96 times 10 to the power 6 meter, or in kilometers that is 1960 kilometer. Now make sure you convert the velocity that is given in kilometers and the length, all these values, into meters before you do the calculation. And let's calculate the acceleration just as an extra thing. So the acceleration is going to be 32 meter per second square. So we see that the acceleration due to gravity is not negligible with respect to this acceleration. Now, since the bar would have to travel nearly this distance, this would not be a very effective launch mechanism using the numbers given. That's the reason why I thought it will be useful to find this acceleration.